Okay, you guys, today we're going to be going into exponents again, but now with division and fractions. So yesterday we talked about the product of powers and the power of a power. And usually it's like addition and multiplication that is required for us to do with handling with those exponents. Now with quotients, like dividing, think about what the opposite of addition is, and that's subtraction. So there will be some sort of subtraction today. Okay. So in our formula chart, we will have these properties of exponents, and it'll give you a little hint as to what to do with those exponents. So as you can see here, the quotient of powers is through subtraction. You're going to subtract the top exponent and the bottom exponent to get your new simplified expression. So a raised to the n minus n. And now when you have a negative exponent though, that's usually a reciprocal. Reciprocal means when you flip the number around. So any number or any value can be put over 1, like a over 1. So a to the negative n really means that you flip this around. So as you can see, this is the negative quotient of the original expression, where it's 1 over a over n. So you just pay attention to this little negative symbol, and it just tells you to flip it around. And as you can see in this end product, there's no more negative. It's gone because we already did the reciprocal, so it gets rid of that direction. So think of the exponents like little directions at the top of your values that tell the number, the base, what to do. Okay, so let's move on. All right, so vocabulary again are exponents, factors. Today we're using the word zero exponent. We're also talking about quotients. We're talking about fractions. Okay, so this is a quotient of powers. This is the first thing that we're going to go over. So at the top it says to divide two powers with the same base, subtract the exponents. So this is a fraction, but it's also a division, okay? So let's not forget that this, even though it looks like a fraction, it's also a division. So when we're dividing c raised to the 11 and c raised to the 8, we will then simplify this fraction by subtracting the top exponent with the bottom exponent. So 11 minus 8, which is c raised to the 3. Okay, so let's go ahead and practice with this one. First thing I got to check for is that the bases are the same. That's the only way you could do this. If the bases are different, you cannot do this, but only when the bases are the same. So 10, 10, base is the same. So I'm going to copy that base down. And now my exponent at the top will consist of a subtraction of 4 minus 2. So when I do 4 minus 2, I get 10 raised to the 2, just like that. This is my answer right here. Okay? Now in this case, there's a lot of components embedded. So I'm going to just separate all of this so you guys can kind of see what's going on. I got 4 over 2, and at the same time, I got n over 8. I mean, n raised to the 8 and n raised to the 7. So I'm going to treat, even though it's all mushed together, I'm going to treat it like two separate pieces. So I'm going to divide 4 by 2 first, and I get 2. And now with this piece over here, I'm going to subtract. So then I'm going to put n 8 minus 7. So my simplified expression would be 2n raised to the 1. Or I could just leave it alone as 2n, because anything raised to the 1 is itself. Okay, now there's a lot of pieces embedded, so I'm going to separate everything again. I'm going to chunk it, my whole numbers first, my x value second, and then my y values third. So there we go. I'm going to do this part first. So 4 over 32. There's really nothing I can do. I can simplify it though. And so the simplified version of this is 1 over 8. And here I get, I subtract. So 7 minus 4 is 3. So then I get x raised to the 3. And then here I'm going to subtract again. 5 minus 2 is 3. Y raised to the 3. So I'm going to take all of these components, all of my my answers, and piece it together as one final expression. So I'm going to do 1 over 8 x raised to the 3 y raised to the 3. And this is my final answer.